1, 2, 3. On September 18, 2003, Hurricane Isabel made landfall as a Category 2 hurricane between Cape Lookout and Ocracoke Island in North Carolina, with wind speeds up to 105 miles per hour. The storm tracked northwest through North Carolina, Virginia, West Virginia, and into Pennsylvania, causing over $5 billion in damage. The storm became extratropical over Pennsylvania and tracked into Canada. Isabel was one of the most damaging storms to impact the mid-Atlantic states since Agnes in 1972 and Hazel in 1954. Isabel was compared to the Great Potomac Chesapeake Hurricane of 1933 in Virginia and Maryland in terms of storm surge and damage to the coastline. These are some of the pictures from the damage from Isabel. The lower right picture is of my sister's house in Pungo. We were without electricity on Knott's Island for 14 days. In the county, this also meant that we had no running water. Although beautiful when photographed from space, hurricanes are violent storms that form around the equator. Their structure is always the same, but what makes a hurricane destructive is the fast winds as it moves through water and reaches the coast. What is the difference between a hurricane, a cyclone, and a typhoon? Pause. Although beautiful when photographed from space, hurricanes are violent storms that form around the equator. Their structure is always the same, but what makes a hurricane destructive is its fast winds as it moves through the water and reaches the coast. So what's the difference between a hurricane, a cyclone, and a typhoon? Nothing, except for geography. Tropical storms occur in several of the world's oceans, and except for their names, they are essentially the same type of storm. In the Atlantic Ocean, Gulf of Mexico, and the Eastern Pacific Ocean, they are called hurricanes. In the Western Pacific Ocean, they are called typhoons. In the Indian Ocean, the Bay of Bengal, and Australia, they are called cyclones. Tropical wave. These are the most common disturbances, with about 100 forming each season. They lack close circulation, which is when there are winds in every direction. Wind speeds are less than 20 knots or 25 miles per hour. A tropical depression, a wave has become a depression when there's a presence of a closed circulation and sustained winds of about 20 knots or 25 miles per hour. At this point, the system is still quite disorganized. Tropical storm, a depression becomes a tropical storm when showers and thunderstorm activity move over closed circulation and sustained winds reach at least 35 knots or 39 miles per hour. At this point, the system is capable of causing minimal damage. And then a hurricane. A tropical storm becomes a hurricane when the closed circulation becomes an eye and the sustained wind reaches at least 65 knots or 74 miles per hour. At this point, the system is capable of causing significant damage. So let's talk about the anatomy and the causes of a tropical disturbance. So as water vapor arises from warm ocean water, pause. So let's talk about the anatomy and causes of a tropical disturbance. As water vapor that arises from warm ocean water condenses, it forms clouds and releases heat into the air. This heated air rises and forms columns of clouds. Evaporation and condensation persist and build the columns of clouds taller and wider. A pattern begins to develop, and winds begin to circulate down the center. As this moving formation forms additional clouds, a cluster of thunderstorms is formed, which is known as a tropical disturbance. As the groups of thunderstorm clouds grow even taller and taller, air at the height of the cloud column begins cooling, making it unstable. The process of cooling water vapor releases heat energy, so the air at the top of the column becomes warmer. This increase in temperature increases the air pressure, making winds move outward and away from the high pressure area. Continued movement and warming forces the pressure at the surface to drop. This creates a cycle in which the air at the surface shifts towards the lower pressure areas, rises, and generates additional thunderstorms. Wind in the column begins spinning faster, creating a circular spinning motion. As the winds reach speeds of 25 and 39 miles per hour, the storm becomes known as a tropical depression. As the storm picks up additional speed and winds, and they reach a rate of 39 miles per hour, the depression develops into what is known as a tropical storm. The winds also begin blowing faster and start twisting around towards the eye, or the still center of the storm. In the northern hemisphere, wind direction moves from west to east, and in the southern hemisphere, it moves from east to west. This unique phenomenon is known as a Coriolis effect. We've talked about it before. As the storm continues to pick up speed and wind reach speeds of 74 miles per hour, the storm officially becomes known as a tropical hurricane or cyclone. At this point, the storm is likely at least 50,000 feet high and nearly 125 miles across, and the eye is between 5 and 30 miles wide. The movement of the wind and the force of the pressure in the air create a mound of water at the base of the storm, which can cause catastrophic storm surges as the storm moves inland. Storm surge is produced by the water pushing toward the shore by the forces of the wind moving cyclonically around the storm. The impact of storm pause. Storm surge is produced by water being pushed towards the shore by the force of the winds moving cyclonically around the storm. The impact on surge of the low pressure associated with intense storms is minimal in comparison to the water being forced toward the shore by the wind. To form, hurricanes need all of the right ingredients. As such, these tropical storms occur near shores and coastlines. In particular, the Atlantic and Pacific Ocean produce the highest number of tropical cyclones. More specifically, the Western Pacific tends to generate far more hurricanes than the Atlantic. Depending on where the storm generates, a number of areas may be impacted, including the Philippines, the Bahamas, Puerto Rico, the southern United States, including Florida, South Carolina, North Carolina, and Virginia. To date, only one hurricane has ever formed in the South Atlantic, and that was Hurricane Katrina, because of how hurricanes actually form. Most Atlantic cyclones form between August and September. In any case, the atmosphere has a lot to do with the creation of tropical storms. To form, the right conditions must align, including warm sea surface temperatures, typically greater than 80 degrees Fahrenheit, weak vertical wind shear, moist, unstable atmosphere, an appropriate distance in relationship to the equator. So how does a hurricane die out? Well, cutting off the storm's energy supply by moving it over a cooler ocean or landfall. At landfall, they lose an energy source and increase friction to reduce the wind. In the early 1970s, Herbert Safier, an engineer, and Robert Simpson, a meteorologist, developed a scale described the likely effects of hurricanes could have on an area. The scale has 5 categories, increasing in intensity from 1 to 5. Initially, Safier and Simpson created the scale based solely on wind speed. Later, Simpson added storm surge levels. Low atmospheric pressure is also associated with hurricanes. The lower the pressure, the more intense the hurricane. Notice that Category 1 hurricanes are the most frequent to make landfall in the United States. There are a few 4 and 5 category. This is fortunate for us because they are catastrophic in terms of damage and life loss. The anatomy of a hurricane. The eye. The hurricane center is relatively calm, generally clear area of sinking air and light winds. The eye wall is where the strong winds get as close as they possibly can to the eye. The eye wall consists of a ring of tall thunderstorms that produce heavy rains and usually have the strongest winds. Rain bands are curved bands of clouds around the thunderstorm that trail away from the eye wall in a spiral fashion. These bands are capable of producing heavy bursts of rain and wind, as well as tornadoes. There are sometimes gaps in between the rain spiral bands where no rain or wind is found. How is a nor'easter different than a hurricane? Well, a nor'easter is a storm that forms along the east coast of North America. Nor'easters are named after the direction from which the strongest winds typically blow over the northeast states, including New England and the mid-Atlantic states. The storms can bring wind, snow, rain, and flooding to these regions. Nor'easters begin to form within 100 miles of the coast that stretches between New Jersey and Georgia. This area is a perfect spot for the formation of storms. The polar jet stream blows cold air southward out of Canada and eastward towards the ocean. The Atlantic Ocean is warm thanks to the Gulf Stream, a warm ocean current. Where the cold air and warm air meet, a low-pressure system forms. This low-pressure system causes clouds to form and a storm to develop. Upon first glance, hurricanes and nor'easters look similar. However, if you look closely, you'll realize that pause. Upon first glance, hurricanes and nor'easters look similar. However, if you look closely, you'll realize that the spiraling storms in the photo on the right are much further south than the spiraling storms on the photograph in the left. Nor'easters and hurricanes both form over the Atlantic Ocean. They're both also types of cyclones, a storm that has wind spiraling around a central low pressure zone. There are some key differences, however, between the two. For example, hurricanes originate over warm waters of the tropic. Pause. Upon first glance, hurricanes and nor'easters look similar. However, if you look closely, you'll realize the spiraling storms in the photograph on the right are much further south than the spiraling storm on the photograph on the left. Nor'easters and hurricanes both form over the Atlantic Ocean. They are both types of cyclones, a storm that has winds spiraling around a central low pressure zone. There are, however, some key differences between the two. For example, hurricanes originate over the warm waters of the tropics, the region near the equator. Nor'easters originate further north, near the eastern coast of the United States. Also, nor'easters thrive and pick up strength from cold air in the atmosphere, while hurricanes thrive on warm air. Nor'easters form off the eastern coast of the United States, in blue, while hurricanes are most likely to form in the tropics, noted in orange. Nor'easters can happen any time of the year, but they are most common between September and April. They are most severe in the winter months. If you hear a nor'easter is headed your way, prepare for bad weather. Nor'easters can produce heavy snow and blizzards, rain and flooding, and huge crashing waves. These waves can cause erosion to the beach and severe damage to nearby buildings and structures. Nor'easters can also produce wind gusts that are even stronger than hurricane-force winds. In 1991, a nor'easter called the Perfect Storm converged on the eastern coast during Halloween weekend. It was the perfect storm not because of its spectacular nature, but in meteorological terms, the weather could not have been worse. All told, the perfect storm of 1991 brought with it widespread flooding, surging waves, rain and snow, freezing temperatures, and up to 78-mile-per-hour winds. It killed 13 people and caused hundreds of millions of dollars in damage in states ranging from Massachusetts to Florida. Hundreds of homes were destroyed during 3 days of heavy rain and wind. What started as a nor'easter in March of 1993 ended as a disaster dubbed the Storm of the Century. In its wake, record snowfalls, coastal flooding, record low temperature, tornadoes, and 318 people lost their lives. There was a hard look at communication failures that took place in the days leading up to the storm. The storm of the century was a product of an unlikely union. Three massive and separate weather systems unexpectedly mingled over the Gulf of Mexico and affected states along the East Coast from Florida to Maine, as well as interior states that don't often feel the effects or the power of a nor'easter. After the 100-year storm had run its multi-day course, 2.5 million people were without power, and up to $6 billion in damage had been reported. For the first time in history, all of the major airports on the eastern seaboard were shut down at the same time. In addition to the damage for people and property, the storm highlighted the importance of communication between national forecasters and local officials. In Florida, which bore the brunt of the storm, it damaged 18,000 homes in areas recovering from the previous year's Hurricane Andrew. Yet the state emergency officials said they were not properly notified of the storm's magnitude. As a result, the National Oceanic and Atmospheric Administration instituted a new process to more effectively forecast weather threats and develop more accurate snowfall prediction models.